Right now, while you're watching this, a black hole the size of a single atom could be passing straight through your body, and you'd feel nothing. No pain, no flash of light. That's not science fiction. Physicists are hunting for these things right now, and they're just one of six. 6 types of black holes, from smaller than an atom to heavier than an entire galaxy. By the end of this video, you'll understand every single one of them. But first, I have a question for you. The biggest black hole we've ever found, how many times heavier than our sun do you think it is? 100 times? 1,000,000? Lock in your number right now. Really, pick one. Because when I give you the real answer near the end of this video, whatever you just guessed, you're not even close. And if you like traveling through the universe like this, subscribe. There's a whole cosmos left to cover, and you're invited. So let's start at the very bottom of the scale. And here's the twist. The smallest type of black hole is also the one nobody has ever seen. They're called primordial black holes. Every other black hole in this video was born when a star died. These weren't. They were born in the first second of the universe. Right after the Big Bang, everything was so hot and so dense that some regions just collapsed. No star needed. Space itself crushed into a black hole, and the sizes are ridiculous. A primordial black hole could be smaller than an atom and still weigh as much as a mountain. Let me say that again. Smaller than an atom, heavy as a mountain. Stephen Hawking did the math on these back in 1971, and here's the part that keeps physicists up at night. There could be billions of them drifting through the galaxy right now. Some scientists think they might even be dark matter, the invisible stuff that makes up most of the universe, which means the smallest black hole on this list might secretly be running the whole show. Remember the one that could be passing through you right now? That's this one. But an atom-sized black hole is nothing compared to what happens when a real star dies. Type 2, stellar mass black holes. This is the classic, the one you picture when someone says black hole. Take a star at least 20 times heavier than our sun. One day, it runs out of fuel, and a star that big doesn't fade out. Its core collapses in on itself in under a second. What's left is the mass of 10, 20, 50 suns, crushed into something the size of a city. Picture that, 10 suns, the size of Paris. And these aren't rare. Our galaxy alone should contain about 100 million of them. 100 million, just in our galaxy. The closest one we found is called Gaia BH1. It's about 1,500 light years away, which sounds far. In galaxy terms, that's our backyard. Okay, pause for a second, because between this type and the next one, there's a gap. And that gap is one of the biggest unsolved mysteries in astronomy. By the way, if your brain is enjoying this, the subscribe button is right there. Okay, the mystery. Here's the problem. We found small black holes, tens of suns. We found monsters, millions, even billions of suns. So you'd expect everything in between, right? Medium black holes, hundreds to thousands of suns. And for decades, almost nothing. It's like discovering a world full of babies and giants, with nobody in between. Then, in 2019, gravitational wave detectors picked up a signal. 2 black holes had slammed into each other, roughly 7 billion light years away. The crash lasted 1/10 of a second, and the object it created weighed about 142 suns, the first solid evidence of a black hole in the missing middle. For that 1/10 of a second, the collision put out more power than the light of every star in the observable universe, combined. So why are these so rare? Nobody knows. Honestly, astronomers openly admit this gap shouldn't be this empty. But the next type has the opposite problem. They're everywhere. There's one at the center of almost every galaxy, including ours. 4 million suns. That's the weight of the black hole sitting at the center of our galaxy, right now. It's called Sagittarius A-star. It's 26,000 light years from your couch. And here's the part nobody ever tells you. You orbit it. You, personally. Right now, you're moving around that black hole at over 500,000 miles per hour. You, your house, the sun, everything you've ever known, and you can't feel a thing. And in 2022, we photographed it. Think about that. We took a picture of the black hole our entire galaxy revolves around. It took a telescope effectively the size of planet Earth, 8 observatories linked across 4 continents to see it. But 4 million suns is small for this category. The first black hole we ever photographed, back in 2019, sits in a galaxy called M87. That one weighs 6.5 billion suns. 6.5 billion! And your guess from the beginning of this video? How's it holding up? Because we're still not at the top. Remember my question? The biggest black hole we've ever found? Here's your answer. It's called Ton 618, and it weighs 66 billion times the mass of our sun. 66 billion! I need you to actually feel that number, because your brain just heard big and moved on. Our sun holds 99.86% of everything in our solar system. Every planet, every moon, every asteroid, all of it is rounding error next to the sun. Ton 618 is 66 billion of those. This one object is probably heavier than all the stars in our galaxy put together. If you dropped Ton 618 into our solar system, its event horizon, the point of no return, wouldn't just swallow the planets. It would reach about 40 times farther out than Neptune. Light, the fastest thing in the universe, the thing that circles Earth 7 times in 1 second. Light would need about 2 weeks just to cross it. So, whatever number you locked in at the start, did you say 66 billion? Tell me in the comments what you guessed. I want to know how close anyone got. Which brings us to type 6. And this one is different, because type 6 is a prediction. In 2020, physicists proposed a category for black holes even bigger than Ton 618, 100 billion suns and beyond. And they gave them possibly the best name in all of science: stupendously large black holes. That's the actual term. It's in the papers. Nobody has found one. And here's why that matters. Some physicists calculate that black holes basically can't grow much past 50 billion suns. The universe hasn't had enough time. So if we ever find a stupendously large black hole out there, it means something happened in the early universe that our physics can't explain. One discovery, that's all it would take. So let's run it back. Black holes smaller than an atom that might secretly be dark matter. Dead stars the size of a city. A missing middle we can barely find. Ton 618, heavier than a galaxy's worth of stars. And a sixth type that would break physics if it exists. That's the whole family. But here's the part I can't stop thinking about. You've been orbiting a black hole your entire life. Every lap you've ever taken around the sun happened inside the grip of Sagittarius A-star. And the calcium in your bones, the iron in your blood, that was forged inside dying stars. The same deaths that leave black holes behind made the ingredients for you. Tell me in the comments which type you'd least want to meet. I read everything. If this messed with your head, share it with someone whose head deserves messing with. It genuinely helps. And wait until you see what happens when scientists fire single particles at 2 tiny slits. That experiment broke reality itself, and it's on screen now.